In example 6, we're given information or a function that tells us about the percentage of the U.S. national income generated by non-farm proprietors. So it can be modeled by this function, where x is the number of years since 1970. So the first thing we're asked to do is find where this function has an inflection point. So asking Wolfram Alpha to give us an inflection point for this function, we get a result of x equals 82/13. If we click on that result, 82/13, we'll generate a decimal approximation for that. So at about 6.31. So we have an inflection point at 6.31. And then we're asked the percentage of U.S. national income generated by non-farm proprietors started decreasing at a slower rate after 6 years after 1970, so 1976. Then we're asked to provide a graph of this function on the interval from 0 to 40. So if I go back here, I've got my original function to save myself some typing. So we can graph this function for 0 less than or equal to x is less than or equal to 40. So in this case, what we had is at x equals 6, right about here, that inflection point occurring. But what we can see is that here, that inflection point occurred because our function changed from concave down to concave up. So in this case, this particular application wasn't actually an example of diminishing returns. In this case, what we're actually looking at is a case of increasing returns. So instead of looking at where a function value started increasing at a slower rate, we were actually looking at where our function started decreasing more slowly. So similar concept, just the reverse idea of concavity changing from negative, so concave down, to positive for concave up. In our last example, we have a company that estimates it will sell N units of a product after spending X $1,000 on advertising. So the first thing we want to do is find any inflection points. In this case, we get two different inflection points. We get inflection points occurring at 10 and 36. And actually, a third typo in this set of notes, let me update this. This domain should be from 24 to 45, not to 25. So we have two different inflection points to consider. In this case, we can easily disregard this value for 10 because this function's domain is values between 24 and 45, meaning 10 is outside the domain, so not a point that we're going to consider. So this means that we'll see sales start growing at a slower rate after 36, which in this case is in thousands. So after $36,000 have been spent on advertising. The last part of this question then asks us about the maximum rate of change of sales. So keep in mind, the rate of change of sales is given to us by the derivative of that function. So what we want to do is find when that maximum rate of change of sales is occurring, should be occurring at x equals 36. So we want to evaluate the first derivative at 36. So the first thing we need to do is find the derivative of this given function. And then evaluate the derivative for x equals, in this case, 36, that point of diminishing returns. And we get a result of 3,888. So the maximum rate of change of sales is 3,000. I accidentally changed the color there and erased some results. So I'm not sure what this program did to me, but erased some of my stuff. But what we have is inflection points at 36 and 10. 10, which we can throw out because the domain is from 24 to 45, meaning after $36,000 have been spent, our sales will start growing at a slower rate. And then evaluating the first derivative at 36 gave us this result of 3,888. So our maximum rate of change of sales is 3,888 sales per $1,000, and my program decided to erase that information again. So I apologize for that, but the nice thing about videos is you can go back, rewind, and collect that information again.